Hello, my name is Piotr Stebnov, and along with Joseph Anderson, our climate indicator project was the autumn Eurasian snow cover. Our hypothesis was the extent of snow cover in autumn on the Siberian basin correlates to cold weather outbreaks and winter weather on the east coast of North America. Our motivation included things like indicator of our seasonal winter activity. Also, because the East Coast is such a hub for imports and exports, it heavily influences their economy. Transportation-wise, it causes potholes and also takes a lot of money to clear the roads and get people to work. Furthermore, it helps us to give us a better seasonal outlook. And with infrastructure cost, roofs are caved in, and also it takes a lot of money to clear everything. Health hazards wise, there's hypothermia, and then there's people who are homeless who are affected by this. Effects on the East Coast, environmental wise, New York City alone spends about 500,000 tons of salt on snow removal. This affects the water quality, especially in streams and rivers, and can erode soil and damage trees and vegetation. Furthermore, many animals, they try to eat the salt on the road, and that leads to them dying as roadkill, or it just makes them really sick and they die anyway. Economic-wise, from just the snowstorm in 2016 this year, the DC area lost about $570 million due to the storm, or about a quarter of their total economic activity for that 3-day stretch. By contrast, the New York metro area lost about $460 million, or roughly about 7% of their GDP. Forbes estimates that it costs New York City about $2.5 million per inch to clear ice and snow in 2015.
So in order to develop this idea between the relationship of autumn Eurasian snow cover and North American winter weather, we got to show, and the models have shown, that anomalous winter weather in Siberia leads to predictable anomalous winter weather in other parts of the world. The main purpose of our study is to examine the Eurasian snow cover anomalies in the past 50 years and the relationship to Arctic oscillation phasing. So in order to define this Arctic oscillation phasing, we want to develop the mechanism of energy transfer from the surface in Siberia to the upper atmosphere across the mid-latitudes and provide that framework of Arctic oscillation-driven weather patterns. If you look to your bottom right, the first image is the Arctic oscillation in the positive phase, showing colder air trapped up by the North Pole and the cold air moving over the North Atlantic, and storminess moving across the Atlantic Ocean to Europe. If you look to the negative phase, we see less cold air up by the North Pole, so that cold air is spilling down into the mid-latitudes, develop more storminess across North America, and more cold storminess over Europe. So in layman's terms, more snow in Siberia leads to more variability in the jet stream. More development of the mechanism, as we of course see that increased snow in Siberia during the autumn months. This creates a broad area of high pressure over that area, which creates cold, sinking air, strengthening that high pressure through the winter months, which that energy, of course, propagates up into the atmosphere, creating warming polar vortex events called stratospheric warming events, which breaks that down, allows that cold air to start spilling across the mid-latitudes, developing that propagation of the jet stream that you see in the far right picture, which just creates more winter weather. So of course our methods, we're going to show that anomalous snow extent on the bottom left, how that correlates with that negative Arctic oscillation phase that we've defined, and how then that will create the bridge to the North American snow cover.
With characterization, anomalous winter weather will be defined by the Climate Extremes Index from the National Center for Environmental Information. The following data categories will be tested, such as record low temperatures and also record one-day precipitation. We'll be comparing the anomalous winter weather across the Northeast with yearly Eurasian snowfall anomaly graphs. Snow extent data will be parameterized to about 14 million square kilometers as a maximum. And with the Climate Extremes Index, the overall percentage of the Northeast that has experienced minimum temperatures will be much below than normal, clearly showing an abnormality in a given year. And the extreme moisture will result in twice the levels of normal precipitation, which will be done strictly from a one-day precipitation event. And extreme conditions will be calculated as those setting records within the 10th percentile of all historical data.
So starting with record minimum temperatures, this graph shows the anomalies from 1967 to 2015. To the left, you see the percentage of the Northeast with record-breaking low temperatures. So, for example, we have 1970, about 45% of the Northeast experienced minimum breaking low temperatures. Again, with record precipitation, here also with 1970, for example, we show that almost 30% of the Northeast experienced record-breaking precipitation in that year. So with those two variables overlaid with the Eurasian snow cover extent, we can start to show some correlation between these data points. And the expected results, we really want to see that correlation between the extensive Siberian snow cover and the record-breaking winter weather over the Northeast of the United States. And the results that we found, graphically we have shown correlations between record autumn Eurasian snow cover, the record winter minimum temperatures, and the record winter precipitation in the Northeast. Years with the positive correlation between the snow cover and minimum temperatures are as follows, and then below that we have the correlation between Eurasian snow cover and winter precipitation. And through this we can tell you that the minimum temperatures and the record winter precipitation are independent of each other, but also dependent on that Eurasian snow cover. This can provide a framework for further research into this, and we want to thank you for watching our presentation.